So whatever content we have in week 2 that are here, that is the first part is complex variable, or we can say complex function. I hope you can hear me clearly.
Yes, sir.
Yeah. And then another important part is coming, that is mapping. Okay. Then whatever I have seen from BUX part, that this third part or third content is coming limit, or you can say limits of a complex function, or, or we can say what is the epsilon delta proof. Okay, we have to check whether limit of a function at a given point exists or not. At the same time, you must have seen some theorems on limits. And after that, the next section is coming, it is differentiation. So already you are familiar with the differentiation of real valued function. Now here you will see how we can differentiate complex valued function. That means a function where a complex number is involved. Okay, so we are going to start from the very beginning of week 2 contents, because I think you have already the basic idea of week 1 contents. So it's wise to start from week 2 since it is your uh, quiz to first quiz syllabus. Okay, so first of all, let's start from complex variable. So already you have submitted 1 or 2 assignments. So I think you have the basic ideas of all these things. But I am just, whatever I am doing here, I am just trying to recall everything here. Okay. So first part is, you must know that a complex number has two forms. So first one is rectangular. We can say it is Cartesian form, and the second one is polar form. So in rectangular or Cartesian form, you know that the complex number z is equal to x plus yi. So the important part is we have to figure out that what is Re of z. It defines the real part of z. So you can see that x plus yi, this is written as z. So from this part, x is the real part, and im of z, that is imaginary of z, that is this one, y. So this part is important. Similarly, we can express any complex number in this form. You already know z equal to r e to the power I theta. So since this is the beginning of this session, so that's why I'm trying to recall all these things at first. Otherwise, there may be some problem whenever I will move to mapping or limits or differentiation concept. So this is the polar form, and you know that r is the modulus, that is the distance from origin to the complex number. That means any complex number z equal to x plus yi can be written or can be thought to be a point xy. So let's say this is x comma y, then the distance from origin to that point is written as, or we can say this is r, that is the modulus, and this angle from positive x-axis to that line, it is the argument. Okay, so at the same time we must know that r equal to square root of x square plus y square, and theta equal to tan inverse y over x. We know this theta can take multiple values. Okay, that means you can see here theta may be suppose 45 degree or 60 degree. Then after coming from positive x-axis to 45 degree, we are getting this one. If we extend our idea and if we come by this way, by counterclockwise, that means with theta, if we add 360 degree, we will get the same part. Again, same thing will be for this. We can add 360 degree again. So that means this process is a continuous process. Similarly, what we can do, we can, let's say this is the point x comma y, and this is r, this is theta. So this time we can come by clockwise. That means here we have theta. If we take negative 360 degree, we will get the same line. We can again come by this direction. So we can again add negative 360 degree. So that means you can understand that this theta, that means the argument, what we know in this way, ARG, argument of this complex number Z is actually theta. That is now tan inverse of y over x, or we can say r tan of y over x. So these are the two different notation. It is looking different, but actually the meaning is same. It is inverse tan y over x, and it is r tan, but the meaning is same. So we often use this one. Okay. So another concept is, what is principal argument? From Slack, I have seen that you you have some confusion in figuring out argument, small arg. You can see this one, and principal argument. So principal argument is denoted as by this way, that is capital A. So arg of this complex number z, that is the principal argument. Remember, principal argument must be in between negative 180 degree to positive 180 degree. It can be also equal to 180 degree. So now think about all the arguments. I have already mentioned that this argument theta can take multiple values. So you are getting, suppose theta equal to negative 50 degree, theta equal to negative 360 degree. You are getting theta equal to, let's say you have 150 degree, you have 170 degree, and theta equal to 180 degree. You have theta equal to 360 degree, you have theta equal to 720 degree. So that means i have written I have written multiple values for theta. Let's say this is some arbitrary point x plus yi. For this complex number, we have found all these argument. So now let let's figure out of this argument, out of these arguments, which one is the principal argument. Okay, this thing is also important whenever you will start your week 3 contents, that is logarithmic function, exponential function. So that in that part you will see there is a concept that we know that this is logarithm of z. There is a difference between this log and this one. Can you hear me?
Yes, sir.
Yes, sir.
So you can see that I have written two parts, that is small l and capital L, lowercase and uppercase. So logarithm of z, that is going with somehow small a r g, and there is a relation between this and this. So since here we have capital L, so that must be coming from this one, because here we have a capital A R G. So this notation is widely used in our reference books just to figure out that the small argument and this one capital A, this argument are not same. But the concept is the principal argument must be in between negative 180 degree, let's say in radian negative pi to positive pi or equal to pi. So now let's figure out of this all angles which one will be the principal argument. You can see negative 360 degree is not in this region, but negative 50 degree is here. Positive 150 degree can be taken. Positive 170 degree is also taken. Since here we have equal, so 180 degree can also be taken. But 360 degree is outside this region, and 720 degree is also the same. So out of this all angles or argument, the principal arguments are, let's say this is capital A, negative 50 degree, negative, okay, 150 degree, then 170 degree, then 180 degree. So all these are principal arguments. Is that okay? We have taken one random complex number, let's say, and for this we have found all these points. And those who were present in my secondary consultation, you know that I have delivered some contents for that. So you can have a look there so that you can figure out how we can find small arg. That means the main argument, okay, theta. This can which can take multiple values. It will depend on the four quadrants. If a complex number is here, that is simply theta. If a complex number is in second quadrant, so there may be a correction. Okay, if a complex number is in third quadrant, so whatever angle we are getting from this formula tan inverse of y over x, so we need to correct something. We need to add either plus 180 degree, or we have to, let's say we need to add plus 360 degree if we have a complex number in fourth quadrant. So depending on the fourth quadrants, we can find the multiple values of argument. Okay, so let's come to the point. Just like the forms of complex number, that is z equal to x plus yi and z equal to r e to the power I theta. Now we are going to the main part, complex variable or complex function, or you can say complex valued function. That is the function where complex variable is involved. So we widely use f of z as complex valued function, and that will give us an output that is denoted as w. Okay, so besides this form, that is z equal to r e to the power I theta, you must know that we have another form, z equal to r cosine theta plus I sine theta. Here, how we can write this one? It is by Euler identity. It is Euler. Mathematician Leonhard Euler. So that's why you can see the spelling, it is written as Euler, but the pronunciation will be Euler. Okay. So mathematician Euler said that e to the power I theta is actually cosine theta plus I sine theta. So this is the powerful equation. Okay. So polar form, complex number that is in polar form, it can take two forms, that is z equal to r e to the power I theta or z equal to r cosine theta plus I sine theta. This is the trigonometric form, and this is the exponential representation. So okay, let's come to the main point. And after this theoretical part, we will try to have a look on some problems so that you can figure out what all the concepts are. And remember, week 1 and week 2 contents will be your upcoming quiz. Okay, will be the syllabus for your upcoming quiz. So we are starting from complex valued function, or you can say complex variable, complex function, or you can say complex valued function. So first of all, let's have a look on real valued function. We know that we must know that y equal to f of x, that is widely used in real analysis. Okay, so where x is the input, that is also known as independent variable, and y is the output, that is known as dependent variable. That means at first we have to input x, then we can expect for y. Let's say we have a function y equal to x plus 1. So here, if we input x, then we can find y. So if we input, suppose we are coming from -2, -1, 0, 1, and 2. We can also take some other values. Okay, let's input -2. So the input, I am using a different color here so that you can figure out this is the input. So here we have f of x, the variable that is inside the parenthesis that can act as input. Okay, you can see x is inside this parenthesis or this bracket, so we can say x is the input. So now if we input -2, we will get -1. For -1, we will get 0. For 0, 0 plus 1 is 0. For 1, we are getting 2. For 2, we are getting 3. So now tell me, try to respond. Is it possible to get y without inputting the values of x?
No,
No,
sir.
sir.
No, sir. Yeah, that means at first we have to input some values of x, then we can expect the value for y. So this is the input and output. That means the relation between domain. You can see here we have the input. Input is called the domain for that function, and output, that is range, is the output, or y, or the dependent variable can be the range. So first thing first is how we can represent this real valued function. So for representing real valued function, we need Cartesian coordinate system. That is, here we have x, here we have y. Without having this idea, we can't understand the intuitive approach of complex variable or complex valued function. So first, we must have to understand what is the representation of real valued function. So here, whatever we have taken, you can see we have taken one function y equal to x plus 1. So we can easily draw the function. That is, at first figure out the domain. Here we have, in domain we have taken -2, -2, -1. So -2, -1, 0, 1, and 2. So for domain we need x-axis. Is that okay?
Yes, sir.
So for range, here we can see the values that we are getting. Uh, if we input 1 here, sorry, 0 here, it will be 1. Yeah. So let's input the values of y. Here we are getting -1, 1. Let's say this is 2. If we extend y-axis, don't worry, I am with you up to 11:40. So I will try to review all the contents that we have in week 2 so that you can have a good practice at your home. Okay, so
Thank you.
welcome. -1, 0, +1, +2, +3, +4. So for range we are using y-axis. That means for tens we need y-axis. We are just discussing about real valued function. So now how many dimension we need just for real valued function? You can see x-axis, so that is one dimension, it is one dimension, it is another, y-axis is another dimension. So we need two dimension. We can also think about multiple valued function, that is discussed in actually in math 216, where you will get to know the three-dimensional curves. Okay, that means x, y, z, where x, y will be the input and z will be the output. But for now, I am just discussing about two-dimensional part. So for domain, we need one axis or one dimension. For range, we need another dimension. So that means we need actually two-dimensional surface. So -2, -1, that is a point. So -2, -1 will be here. -1, 0, that is here. 0, 1 point, this is here. 1, 2 point, 1, 2. So now we don't need other points. We can join all these points and we have the graph. So the advantage of real valued function is we can have the domain and range in the same plot. Okay, in the same Cartesian axis, we can figure out the domain part and range part. But we are here to learn complex variable and complex valued or complex valued function. So things will be different than real valued representation. Okay, so you will understand now that. So be sure that for real valued function we need two dimension. That is, x-axis is acting as the first dimension, that is the domain, and y-axis is the range. We can also represent this domain and range by this way. You will understand now what I am saying, that you are familiar with this set notation. That is, this is x, this is y, and we are inputting x, we are getting y. So there is a mapping where F maps x to y. If we input -2, -2 is mapping to -1. -1 is mapping to 0. 0, 0 is the input, that is x value. So 0 is mapping to 1. So similarly, we can extend the idea for other values. So this is the representation what we have learned from our college or school level or high school level. So this is domain, and this part is the range. Same idea will be applied in complex valued function. So first of all, just like real valued function y equal to f of x, we represent complex valued function in this way, w equal to f of z. And remember, inside z we have either x plus yi, that is the rectangular form of complex number, or the polar form r e to the power I theta, or we can say r cosine theta plus I sine theta. Okay, so that means this z can take these representations. Okay, so just like real valued function, x is the input, y is the output. Here we have also z is the input. After inputting z, we will get the output. Remember, z is a complex number, so we are inputting complex number here in that function. The output must be a complex number. So in that case, you can have a look here. We are inputting real value. The output is also a real value. That is for real valued function. And the same idea is for complex valued function. Now, you will be surprised that suppose we are inputting some value, that is 1 plus I, and we are getting a real number 2. So we are inputting complex variable, that is complex valued part here, that is 1 plus I, that is in rectangular form, and we are getting the output that is looking like real number. But is that so? Is it real number? Since we are lucky that we have complex analysis. That means complex number set is one of the largest set, and R, that is real number set, is the subset of complex number. That means any real number 2 that can be considered as 2 plus 0i. So here 0, that means 0i is telling us that this 2, despite being a real number, it can be a complex number. It doesn't matter that we have no imaginary part, but this is actually a complex number. So you will be surprised that whenever we are inputting some complex number, output may be real number, may be complex number, but if it is real number, be sure that that is also a complex number. So okay, f of z equal to w. Now what I have said, that w equal to f of z, if z is complex number, w will be also complex number. So since z can be x plus yi form, or z can be r e to the power I theta form in this form, so that means finally the output w, that must have also a real part and an imaginary part. That means it will be also in this form, a plus bi, or we can say it will be in x plus yi. So in complex variable or complex valued function, what we denote that this real part is denoted as u and this imaginary part is denoted as v. So there are two possibilities. If we are inputting this rectangular form, then this u will be obviously of xy. That means it will be a function for xy. And this v will be obviously a function for xy. Then we can add up. So w, or we can say f of z, finally the output will be in this form, u plus vi. Or since we have the other form r e to the power I theta, if we are inputting r e to the power I theta, then w, that is it will be u plus v again, but this time it will be of r comma theta. V will be a function for r comma theta also with I. That means it is of a plus bi form. So from complex valued function, sometimes, that means most often, it is wise to find these two parts, because whenever uh, we need to check the limiting concept, or we need to evaluate the limit. Suppose we are going to check the differentiability, then for some functions we need to find out u and v separately. Okay, so just like real valued function, I will I will try to show another example so that you can figure out which part is the input and which part is the output, and how we can represent very complex valued function in Cartesian coordinate system. So here, let's say we have a function f of z equal to 2 plus z. I am taking one simple function. Now we can extend our idea just like real valued function, whatever we have done there. That is, this time we are inputting z and we are denoting the output as w. So this will be the domain and this must be the range. Remember, in complex valued function, domain is also called, okay, at first, let me say this one. Range is the image, and same thing is for real valued function. Range is called the image. Y is the image of x. That means if I ask you what is the image of -2, it is -1. Image of -1 is 0. So image is not often used. That is, we can say -2 is mapping to -1. -1 is mapping to 0. 0 is corresponding to 1. We are familiar with corresponding or mapping words. Okay, but we can also say range can be thought to be image. So if so, then domain is the pre-image. Okay, because sometimes the question pattern will be different, so you have to also know the alternative notations. Okay, so domain can also be thought as pre-image and range is the image. Okay, so we can input any value that must be a complex number, but let's say we are inputting a real number, so a real number is also a complex number. So here you can see z is the input. If we input 0, what will be the result? W will be 2 plus 0 is 2. So we are inputting at first z, then we are getting w. If we input 1, then we will get 2 plus 1 is 3. So same thing we can do here. That is, this is the domain z and this is the range w. So we are inputting 0 and the output that we have here, that is 2. For 1 we are getting 3. Now, since we are discussing complex valued function, so let's say this 0 is not actually 0. It has 0 plus 0i. 1 is 1 plus 0i. 2 is also 2 plus 0i. 3 is also 3 plus 0i. Okay? But finally the result is becoming 2 and 3. So you will understand if I take another value. Now this time I am going to take 2 plus 3i, where we have z. So let's input 2 plus 3i. So the function that we have w equal to 2 plus z. So inside z we are inputting now 2 plus 3i. Let's see what will be the output. So 2 plus 2 plus 3i, that is simple algebra. So 4 plus 3i. You can see the final result we have found 4 plus 3i. This time we can say the input is 2 plus 3i, and we are getting the image of this, that is the output is 4 plus 3i. Is that okay? Do you understand?
Yes, sir.
Yes, sir.
Okay, let's take another value of z, that is negative 1, negative 2i. So in this part, now inside this z, we will input negative 1, negative 2i, so that we can have this output. So we are getting 2, negative 1, negative 2. Again, I am using simple algebraic technique. So now sum of this 1, negative 2i. So the actual output that we have found here. So whatever I am doing here, that is the main basic concept of mapping. So I have found 1, negative 2i. So let's say we are inputting negative 1, negative 2i, and we are getting the output as 1, negative 2i. So you know that, so up to now it is okay. That's we are inputting one complex variable, that means complex value, that is in rectangular form, and we are getting another complex number that is in rectangular form. This is whatever we are having the mapping. That means f is a mapping that maps z to w. So we can write this one in Euler notation form. F is a mapping where the domain is z and the range is w. This is now widely used, that here z is the domain, or we can say pre-image, and this is the range, it is the image, and this is the mapping that we can say z is mapping to w. So now the problem will be in visual representation. So you can see that for real valued function, we can easily represent the domain and range in the same plane, same Cartesian axis. For domain, we just need x. For range, we need y. Then we have the points. But the problem is in complex valued function. You can see that z, since z is x plus yi, so this is also a point, and f of z, we are denoting this is w. So let's say w is equal to u plus vi. Already I have told you that, already you know from your previous videos or the ux videos, that it is u plus v. It can take x, y, or r theta depending on whatever input we are giving. So the output is also a point, that is now uv. So you can see that z is the domain and f of z or w is the range. So for domain we need two parts. That means just for domain we need x-axis and y-axis at the same time. Is that okay? So x and y together we are having two dimension. For range we need another two dimension u and v. So if we sum up this, the number of domain, the number of dimension that we need for domain and range, then you will get the idea that here whatever we have done for domain, for real valued function we have only one dimension, for range we have another dimension, 1 plus 1 we have two dimension, and that is first dimension and the second dimension. Here for complex valued function, just for domain we need two dimension, just for range we need another two dimension, so 2 plus 2 we have 4. So is it possible we just live in three-dimensional space? So we can think about two-dimensional space and three-dimensional space, but we have to figure out four-dimensional, so it is, which is impossible. Okay, we can just think about x, y, z, but we can't think about that. Here we have suppose x, y, z, all all axes are 90-degree parts. So is it possible? No, it is not possible. So that means we can conclude a comment that we can't draw complex valued function. Okay, so we can't draw complex valued function, but in some sense we can draw. That is, you have seen that for domain or z we just need two dimension, that is x comma y. So here we have x and y. This total part is now acting as the domain. Whatever you have seen in real valued function, this x-axis is the domain. Let's say this is real number x, this is the domain, and this vertical axis is acting as the range. Now we can combine x and y, so we are having domain and range at the same figure for real valued function. But the problem is arising for complex valued function. We have x and y, both are acting as the domain. So let's say xy is the point, it is the input, it is the domain. So in this part, just to plot the output, figure out again a real valued function. We are inputting at first, let's say we are inputting -2, we are getting output 1. So -1, -2 here. We are at first inputting -2, that means it is mapping to then 1. That means we are having the idea in same figure. But for complex valued function, domain itself is taking two dimension. So just to plot complex valued function, we need another two dimension, that is, let's say it is uv. So it's quite difficult to draw the four-dimensional figure. It is impossible. So what we can do, we can just think about domain and range separately. It is domain part, it is range part. It's true that we can't actually draw complex valued function, but what we can see, we can just intuitively think about the representation, the mapping only. So that's why mapping is coming. So let's say x comma y, that is the domain or a point for from domain part. It is mapping to uv. So for xy, we are having x-axis, y-axis, that is real axis, imaginary axis. Similarly, for uv, let's say it is u, it is v. The horizontal line is u, the vertical line is v. So y, v, x, u. So this is, you know that z equal to, that is, okay, let me correct, w equal to f of z. So we are inputting z. That means this is the z plane. It is known as z plane where we have x, y. And finally, we are having the mapping, that is w, where we have u plus vi, that means uv. So it is now known as u plane. Sorry, z plane. Again, I am mistaking. It is z plane, it is w plane. Okay, can you figure out? It is
Yes,
z
sir.
plane and it is the w plane. That means actually we need 4 dimension for complex valued function just to have the actual figure. But we can't draw 4 dimensional figures. We can just think intuitively. So in abstract sense, we can draw the domain in 2 dimensional part separately. We can draw the range in another part. So uh, from this example, so what we can do, for the upcoming quiz, you don't need to uh, have a look on the proofs. Just try to know the statement and try to focus on the problem solving part, because the quiz maybe will be of MCQ type. Okay, there will be some checkbox or multiple choice, whatever you have seen in your weekly quizzes. Okay, so it is just like that. So try to focus on the problem solving part rather than focusing on proofs. Okay, so now we are trying to draw this function, that is a complex valued function, but we can't actually draw the figure. But what we can do, we can draw the z plane separately, where we have x, y. So whole z plane, that is x, y, x axis, y axis, is acting as the domain part. And we have the output that is now known as uv plane or it is w plane. So let's say 2 3. In input we have given 2 plus 3i, so that is actually a point 2 comma 3. So at first we have to locate 2 comma 3 in domain. So 1 2 1 2 3. So this is 2 3 point. So 2 3 point is the input, but for this input we can't locate the output in 4 dimension. So that's why we are taking the help of this way. That is 2 3 point has the output 4 plus 3i, that is also written as 4 3 points. So 1 2 3 4, u axis is acting as x axis and y and v are also same. So let's figure out 4 3 point. So 4 1 2 3, so 4 3 point is here. So what we can say, we can say that this 2 3 point is mapping to 4 3 point. That is the mapping f from z to w. Is that okay? So we can also think about all the points. Let's say -1, -2. This is going with -1, -2. That means 1 -2 will be here. So we can then map all these things. That is the representation. So you will understand if we think about one. Let's say one. We have one square. Square means you will understand now what is mapping. Let's say we have one square. I'm not telling about discussing about rectangle. Let's say we have a square. This one that is in z plane, and for this, let's say we have a function f of z equal to what we can say. mm, let's say randomly we are taking z plus 2 negative I. So we have taken one function where z is the input and finally f of z or w is the output. So for this, under this mapping, so you can easily say that if I write w equal to f of z, that is nothing but a mapping. So from now w equal to f of z will be pronounced as a mapping. Is that okay? So we have a mapping here. For this mapping, we have to check whatever square, whatever shape we have in z plane, what will be the figure or output of this square in w plane. Is it in the same position where just like whatever it is in z plane? That means suppose it is 1 point, it is 2 1 point, it's a, let's say it is 1 2 point, and it is 2 2 point. So is it also same 1 1 1 2 2 2 2 1? That means if whatever points we have in z plane, whatever points we have in w plane, if all these are same, then we can say that this square and this square are same and are living at the same position. Okay, but if but things are not always same, since we have the mapping. So whatever figure we have here, that may translate, that may be magnified. Here we can see one square in z plane. In w plane, it can take another new shape. It may be a circle, it may be a parabola. Okay, so that means whatever shape we have in the z plane, it doesn't matter. It doesn't, so that on w plane we have the same figure. Okay, it may be different figure, it may be the same figure, but it will be in translated form. That means it may shift its position from here to here. So you'll understand now what I am telling about. So the function that we have, f of z equal to z plus 2i, and I have taken 1 1 2 1, then 2 2 point, and 1 2 point. Yeah. So let's try to have a look what will be the mapping for this square that is in z plane. So you can see that we have a square in z plane with the vertices. You can see this is a one vertex or point. It is another vertex. So in sum of, if we in summary we can say all the vertices are with the vertices 1 1 1 1 is also okay. Now let's write by this way. We have the vertices 1 plus I, that is 1 1. In your given question, it may be in this form or in 1 1 form. But remember that every complex number x plus yi is actually a point xy. So 1 plus I Let's say we have 2 plus I, then 2 plus 2I, and we have another vertex that is 1 plus 2I. So whatever point I have shown here, that is written in this way. So now the question is, find the image of this shape or image of all points that is forming a square that is in z plane with the vertices 1 plus I, 1 plus 2I, 2 plus 2I, 1 plus 2I under this mapping, the mapping that we have f of z equal to z plus 2 negative I. So that means this is a complete question and we have to find the image with the help of this function. So again the concept is same. We will input z, then we will get the output. So you can use tabular technique or you can use your calculator. The main idea is finally you have to find the outputs. Whatever method you will apply, we need your answers. Okay. So first point, let's start with 1 point or 1 plus I point. Okay. Where we have to input, at first look at this part, it is z. So inside this, we will input 1 plus I, then 2 plus I, then 2 plus 2I, then 1 plus 2I. So if we input 1 plus I, so 1 plus I, and here we have plus 2 negative I. So now sum up real part, imaginary part, imaginary part. Can you please tell me what will be the result here? It
So
will be
3.
3. 3 plus 0 I only. Is that okay? So I am writing 3. Also, I can write 3 plus 0 I because any complex number, any real number can be thought to be also a complex number. Now, let's input similarly the second one, that is 2 plus I. So inside Z, we are inputting 2 plus I and we have the same part here, 2 negative I. Now use your algebraic technique. So you can see that I and I are cancelling out. We have the result 2 plus 2, 4, right? So we are actually getting 4 plus 0I. Let's input similarly where we have Z. Let's input 2 plus 2I. So 2 plus 2I plus 2 negative I. So this time 2 real part, that is in next statement we can write it like this, 2 plus 2 plus we can sum up real part and we can group the imaginary part. So whatever result we are getting finally, it is 4 plus I. So here we are getting the output 4 plus I. So can you figure out how we can find the outputs? It is just like real valued function. We are extending the idea, nothing else. So for the last part, 1 plus 2I, let's input 1 plus 2I where we have Z and also we have plus 2 negative I. So summing up the real parts, we are grouping here 1 and 2 plus 2I negative I. So we are getting 3 plus I. So we have 3 plus I. Finally, you can see that these points are 1 1, it is 2 1, it is 2 2, and it is written as 1 2. Okay. Similarly, for output, we can write 30, okay, 40, 41, and 31. That means you can easily understand that 1 point is mapping to 30 point, 21 is mapping to 40, 22 is to 41, and 12 is to 31. That means now we are going to have this representation. XY point that is in Z plane that is mapping to W plane. Okay. Uh, can you please tell me why we use Z equal to X plus YI here? And in some books, you will see the you know already that Z equal to R e to the power I theta. That means these are the common notations. But in some books, you will see, you will find this notation that R e to the power I theta instead of R e to the power I theta. In some books, you will see R e to the power Z theta. And I am mentioning, you will find this notation in your electrical engineering book. Okay, those who are from triple E, they are familiar with this type of notation. This is also a complex number in polar form that is going with this one. But can you please tell me why the authors of that reference books are using I instead of I, they're using Z? Do you know the answer? Actually, the answer is in electrical engineering, I is replaced by, when I is known as the current. So that's why if we use I here, so there will be a problem. Okay, two things have the same name. So that's why instead of I in electrical engineering books, you will see J. So that these two parts can be separately figured out. Is that okay? So try to respond. Can you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
From last couple of times, I am just discussing, but there is no response from all of you. So that's why I have asked. Okay.
So
So
that's
now
because we're understanding
yeah,
everything clearly.
yeah. What's your question?
Sir, I have no question. I
Okay,
I mean to say, we didn't respond or question because we are clear everything you are teaching here.
okay. Thank you. So now we are just trying to mapping all these things here. So it is the jet plane. We have the point 1, 2, 2 1, 2, 1, 2. So let's point out. Let's look at all the points that we have in z plane. So you can see 1, 1, 2, 1. 1, 1 will be here. Then 2, 1, 2, 1, 2, 2, and 1, 2. Is there any problem in locating the points in Cartesian coordinate system? Do you have any problem here?
No, sir.
Okay, so now by joining all these points, since in our given question it is mentioned that this is a square with vertices this point, so that's why we are joining all these points. So that means now we have to check what will be the output, okay, in W plane. So in W plane, the real axis is written as u or denoted as u, and the vertical axis is by v. So you can see that here we have 30, 40, 41, 31. So that means let's say it is 1, 2, okay, 1, 2, 3, 4. 1, 2. Okay, just enough. So this is V and this is U. So now we are in W plane. Actually, fourth dimension is not possible. That's why we are separately trying to draw the figure. So here we can see the first point in W. Here we have 3, 0. So 1, 2, 3, and 0 is here. So 3, 0 point is here. Then we have 4, 0. 4, 0 point is here. 4, 1. 4 and 1. That is here. 3, 1. 3 and 1. So now we can join these points. We have again another square, but it is not here. It is shifted its position. Is that okay? So that is the mapping F. Or we can say individually we can say this point, that is 1, 1 point is mapping to 3, 0. So we can use another different color. So 1, 1 point is mapping to this.
Sir,
Let's say
sir, I have a question.
yeah.
Sir, if they tell us to draw to represent W graphically in the question, then
Yeah.
is it necessary to draw the Z plane too? I
uh,
mean, like it's mandatory.
it's wise to give Z plane and W plane at the same time, but if you want to save your time, you can just plot W plane figure.
Okay, sir.
Okay,
Thank
no
you.
problem. So this point is mapping to this one, this point is mapping to this. Similarly, 2, 2 point is mapping to 4, 1 point, 1, 2 point is mapping to 3, 1 point. So this is how we can represent complex valued function. So this is about complex valued function and mapping, but still we have to know elaborately about mapping part. So okay, let's take another example, then we will move to the limiting concept. First of all, let's say we have a function f of z. So I am taking another problem, f of z equal to z squared, where z is a complex valued function. So it is equal to w. So that means this is one mapping. Under this mapping, we have to find, let's say the question is find the image of x equal to 1. We have x equal to 1. Okay, this is the question. Find the image of x equal to 1 under, which is under this mapping. So you know that any complex valued function f of z can be written as u plus vi. That means input is rectangular. Input can be in this form, x plus yi. Output can be also of u plus vi. That means it will have real part and imaginary part. So same idea will be applied here. We have the function f of z equal to z squared. Besides this question, invisibly we have another question, that find the real parts, real part and imaginary part of f of z. let's say this is another question. After figuring out the real part and imaginary part of f of z, we can then find the image of x equal to 1. Okay, first of all, since we have x equal to 1, from the concept of geometry, you know that from geometry, you know that x equal to a is the vertical lines, y equal to b will be the horizontal lines. So obviously, since we have x equal to 1, so that means x equal to 1, let's say this is 1. So x equal to 1 will be a vertical line. Is that okay? So that means in z plane, we have x equal to 1. The figure is looking like this. Now we have to check what is the image of x equal to 1 under this mapping in w plane. That is the intuitive of that question. So it is z plane and it is w plane. We want to know what will be the output here. In w plane, we use u and v. So first question is find the real part and imaginary part of f of z. So our f of z function is z squared. So f of z equal to z squared. You already know how we can find x, how we can find the real part and imaginary part of this. So let's say this is w. So you know that from the very beginning of this course, you were using z equal to x plus I y. So inside z, we are just inputting x plus yi. So here we are getting a plus b whole squared formula. So x squared plus 2ab plus b squared. That means we have x squared plus 2xyi plus y squared I squared. And you know that I squared is -1. So x squared plus 2xyi and I squared is -1. So y squared here only. Now, every complex valued function can be written as u plus vi, or more generally we can say there will be a real part and there will be an imaginary part with I. So let's try to collect the real part, the parts where we have I free terms. You can see x squared and negative y squared don't have I terms. Okay, so these are I free, so we are grouping, and we have I here only. So this is our imaginary part. So we are just coming with this way. So that means f of z, or we say w, is now this one. So the real part of f of z is known as u, imaginary part is known as v. So we can write that we can compare with f of z equal to u plus vi. So what is the functions for u? So we are getting, so from the upper part we are getting u equal to, u is this one, x squared negative y squared, and v equal to 2xy. Okay, just give me 1 minute. You can take the help of any mathematical tool just for the actual graph, or you can draw by hand. I can take the help of Mathematica, or you can take the help of online tools. That is, I am using this one, that is implicit, Desmos implicit function. I am giving this in, the link is in now chat box. Is it okay?
Yes, sir.
Thank you, sir. Thank you, sir.
So previously, whatever function we have, let's figure out this one. Already I have drawn the figure x equal to 1. So x equal to 1, the vertical line, you can see we have found the graph. Now we have to check what will be the image of this x equal to 1. But before that, let's solve again, come to this one. So we have already figured out u part and v part. So just whenever I have started the conversation, you know that I have told you that, or already you know that this u is a function of now xy. This v is a function of xy. So if you are having problem with this xy, for simplicity, you can just write u equal to x squared negative y squared, v equal to 2xy. No problem. You will get marks. You will get full marks. Okay. So now, whatever function we have, finally, we have found u and v. So let's input x. We have already x equal to 1. So where we have x, we need to input the value of x. So that means x is 1. So 1 squared negative y squared, for which we are getting u as 1 negative y squared. Similarly, input v. The steps that I am following for mapping, you can follow the same step for other problems. Okay, that means at first you can find u and v just by inputting z equal to x plus yi, where you have z. Then you will get u function and v function. Then whatever values you have in your, whatever values or whatever function you have in your given question, you have to input this. So this is the steps. So now 2 times 1, we are inputting x as 1, y. So here we have v equal to 2y. That means it's quite difficult to draw this one, 1 negative y squared, v equal to 2y. Actually, this type of forms are called parametric function. You should know this term, because whenever you will start complex differentiation or complex integration, then you will see this part, that is, what is parametric function. Let me describe about parametric function at first, then we'll again come to this one. So it is parametric function. Parametric functions are those, suppose we have x equal to f of theta, y equal to f of theta, or y equal to g of theta. We have another function here. So you can see that x equal to f of theta, y equal to f of theta. But combinedly, these two parts are called parametric function. So from this part, you can see that for x, whatever input, I have already mentioned that the variable that is inside the parenthesis, that is inside this bracket, is the input variable. Remember. So here we have input theta. For x, we have input theta. And for y, we have the same input. So if so, that if x has the same input, if x has the input theta and y has the same input, then combinedly, these two can be written as y equal to f of x. So this form is called the explicit function or explicit form. And this form is called the parametric form. Okay, let's say we have an example, x equal to theta squared and y equal to 2 theta. Then you will understand what I am telling about. So here we have x equal to theta squared, y comma y equal to, or semicolon, y equal to 2 theta. So you can see that x is a function of input variable theta and y is also another function of same input theta. So in that case, we can say this is parametric function. So if we have this one, this is the parametric function. From this, if we need to find y equal to f of x, then what we can do? We can just find out theta from any of the equation or any of the function. So here we have y equal to theta. So theta equal to, it will be y by 2. Then input here. So here x equal to, we are getting theta squared. So inside theta, we can input y by 2 squared. So we are getting y squared by 4. So that means x. So here we have 4x. We can, this is the explicit form. We have also implicit form. Implicit form is f of x comma y equal to a constant 0 or c. Okay, 0. So that means we can write by this way, y squared equal to 4x. This is the implicit form. We can write by this way, y squared negative 4x equal to 0. That is going with this one. Or if we want, we can also write by this way, y equal to f of x. So y squared equal to 4x, or we can say y equal to plus minus root over 4x. Is that okay? So we can see we have figured out y, just y equal to f of x in this form. X equal to theta is from x equal to theta is squared, y equal to 2 theta. So actually here y equal to positive root over x is a function, y equal to negative root over x is another function, but combinedly it is not a function. Okay, it is just a relation. So I'm not going in details what is a function or what is the definition of function. Remember, function can take only one, for one input there will be only one output. But whatever we have here, plus minus, suppose 4 x, if we input x as 1, for x as 1 we are getting plus minus root over 4 plus minus 2. So for this input 1, we have two outputs. So that is not a function, it is just a relation. So try to recall the definition of relation here. We don't need this now. But the main concept is how we can convert parametric function to y equal to f of x. Is that okay? Do you understand my point?
Yes, sir.
Yes, sure.
So now we can see that u equal to 1 negative y squared and v equal to 2y. We have plugged the value of x and found u and v. But just to draw the graph, y equal to, you know that we need f of x. So for this, we need v equal to f of u. Is that so? So what we can do, you can see that u here, u is a function for y and v is another function for the same input y. So that's why these two are forming a parametric equation, parametric function. So from this, what we can do, we can just find y. Again, let me write the same thing clearly. So we have found u equal to 1 negative y squared and v equal to 2y. Just like y equal to f of x, we need v equal to f of u. So for this, we can just find y. So y equal to v by 2. Is that okay? And let's input y here in this function. So we are getting 1 negative v by 2 squared then we have 1 negative v squared by 4. It is just simple algebraic technique. Then what you can do, you can just take the LCM and you are getting 4 negative v squared as u. So 4u equal to 4 negative v squared, and from this part our target is to keep v on the left side. It is already in implicit form. Now we need explicit form. So 4u negative 4, okay, let me correct again. So v squared equal to 4 negative 4u. Is that okay?
Yes, sir.
Yeah. So finally, we have found the mapping. That means, have a look on the given question. That is, what will be the image of x equal to 1 under the function f of z equal to z squared? What will be the image of x equal to 1? So already we have the result. V squared equal to 4 negative 4u. You can keep the value as u and v. Let's say with u and v, it's quite difficult to figure out. Let's say u as x and v as y. Then you will understand that y squared equal to 4 negative 4x. That is, you know that y squared equal to 4ax is a parabola. So similarly, since we have y squared and x with power 1, so it must be a parabola. Is that okay? But I'm trying
Yes.
to I'm trying to give you the insights how we can draw the figure. So at first, let's draw this one. Already we have x equal to 1. And let's say what will be the image of this. So in Desmos, it will not take u and v. So that's why I am using Mathematica. So let's plot the function that we have found for negative for u. Or we can say, do you understand? Already our problem is, our main part is completed. Is that okay? You are getting full marks for this one. We have found the mapping. But we want to figure out that in z plane, we had previously x equal to 1. It is just looking like this figure. But now we want to see what will be the figure in uv, that is w plane. Is it also the same as this vertical line? No, we have found a parabola. Okay, so it will be just like this one, this one. Since we have negative, it will be this one. But at first, have a look from Mathematica. Try to understand that we can write this one as, okay, from this one, v equal to plus minus root over 4 negative 4u, isn't it? Hello?
Sir.
Yes, sir.
So at first, let's take for positive. So here we have positive 4 negative u. And the main variable that we have here, input variable u, we're taking, suppose from -5 to 5, we are getting one figure. Let's draw for the negative portion. We have just drawn the figure for positive, and let's draw for negative similarly. So for negative, part, we will get this one. So let's plot at the same figure. Let's say this is G1 and this is G2. So this and this, here semicolon is acting as, that means the final output is not showing. Okay, so here finally we can have a look on the graph, show G1 comma C2. Okay, let me correct this one. So can you see, we have the figure that is looking like a parabola. Is that okay? That is open in leftward position. Can you see properly?
Yes, sir.
Yes, sir.
So for this function, that means v squared for negative u, we have finally the parabola, leftward open parabola, a parabola that is open in leftward position. You can, since you are using, that means you are appearing your exam from your home, so you can also take the help of in these online tools. But here the problem is it can't take v and u. So in that case, what we can say, we can just input y square negative 4, sorry, y square 4 negative 4x. That will be easy for you. So y is squared 4 negative 4x. So you can see that we have the figure. But if we use uv, so Desmos will not give you the figure. Okay, do you understand? See, we don't have the figure. There is an error. So that's why, just for the graph, if you are using Desmos, then you have to use xy. So the image is now looking as a parabola. That means it is v squared equal to 4 negative 4u. So whatever we have in z plane, the image of x equal to 1 is now a parabola in w plane. Do you understand the insights of this?
Yes, sir.
So
Yes,
whatever we have previously, that is a vertical line, but in w plane, after using the concept of mapping, we have a curve. So I have used the mathematical tool, that is either Wolfram Mathematica or Desmos. But how we can draw this graph by our hand, with our free hand? Do you know how we can draw this graph? Do you want me to show this? If you want, then I can show.
Yes, sir. Please.
Okay. So here we have y squared equal to 4 negative 4x. Okay, forget about this one. We have v squared equal to 4 negative u. So for this, whatever concept I have used in Mathematica, that at first I have drawn for positive and then negative. That means So 4 negative 4u. So what we can do, we can just find v equal to plus minus root over 4 negative 4u. And again, you can use tabular concept. That means, what is the input this time? Input is u and output is v. We want to draw the graph. We want to draw the graph of this function. So we can input any values. That is, remember, this will be, there is a restriction here. Square root of -1 will be I. Okay, so we are not going in details in that part, but let's think simply. That is, if we input, let's say 0, what will be the case? We will get, if we input 0 here, so 4 negative 0 root
4.
of plus minus, that means plus minus root over 4, we are getting plus minus 2. Is that okay?
Yes.
So plus
Yes.
2 and minus 2. So you can see the point, first point we are getting 0 2, that means 0 is mapping to 2 and 0 is also mapping to -2. Clear? Is that okay?
Yes, sir.
Yes.
Let's
Yes.
take another, let's take another value, -1. So if we input -1 here, so plus my v will be plus minus root over 4 negative 4 times -1. So plus minus root over 4 plus 4, we are getting plus minus root 8. So can you please tell what is the numerical value of plus minus root over 8, square root of 8? That is approximately
2.83, sir.
2.8. Thank you. So here we are getting 2.8 and -2.8. Clear?
Yes,
You
sir.
can also see that here we can take 4. Yeah. So let's take positive 4. We can take any random values. So 4, we will get plus minus 4 negative 16. So what we are getting from here, we are getting negative, that means what? No, let's take, this is not 4, it is like 1. Yeah, this point is 1. Let's take 1. So if we take 1, so 4 minus 4 is 0. We are getting 0. Is that okay? So this time we have
Yes.
found the point 1 0. So here -1, positive 2.8, -1, -2.8. The more we take points, the is more we get. That means the graph will be more and more smooth. Okay. So what will be the case if we take 4? So 4 times 4 negative 4 times 4. That means you are getting root over 4 negative 16. So root over -12. Actually, since we have finally converted the main function to this one, so that is now looking like as real valued function. So since it is complex valued function, so for x, for u equal to 4, the function, your calculator will give you error. Is that okay? So that means
Yes, sir.
it is not in the domain. So okay, whatever points we have, that is enough. So let's draw. In u axis, we have taken -1 0 +1. Can you see properly? -1 0
Yes, sir.
+1. Yeah.
Yes, sir. We can
Yeah.
see.
Then in y-axis we have 0. We can see +2, -2. So let's say 1. This is 2. So -1, -2, -3. +1, +2, +3. So now locate the point. This is the time to locate the points. First point, for here we have -1, -2.8, -1, -2 point will be nearly here, right? It is -2, -3, so -2 point is 2.8 is here. Clear? For -1, we have either -1, -2.8, and -1, +2.8. Clear?
Yes,
Yes,
sir.
sir.
At the
Yes,
same
sir.
time, for this one, we can see we have 0, +2, 0, -2. Let's figure out at first this one. 0, -2, 0, -2 is here, and 0, +2 is here. So we are just locating the points. And finally, we have 1, 0. 1, 0 point is here. So we have so many points, 1, 2, 3, 4, 5, that are enough. Now we can join the points. So you can draw the figure by your free hand. Is that okay? So this is the graph of v squared equal to 4 negative 4u. So analytically, by our free hand, we can draw the graph by using this tabular concept. We must have some points, then we can join all the points so that we have the graph. And at the very beginning of this session, I have used the same concept for real valued function. I have taken some values of x, then we are getting y, then we have the points, and we are locating the points, we are joining then the points, then you are getting the figure. So is there any problem in this figure, or do you have any question anymore, or how we can draw the graph
No,
regarding
sir.
this?
No, sir.
Okay, so since you will appear the exam from your home, so I will suggest you, without using this concept, instead of this concept, you can take the help of Desmos. Is that okay? That will quickly give you the graph. Okay.
Yes, sir.
Okay, so this is our main function that is in z plane, suppose, and the image finally we have found this one that is in w plane. Clear? So
Yes, sir.
the concept that I have used here, have a look again on the process. That means, first of all, we have a function, and now under this, with the help of this function, we have to find the image of any part that is in z plane. So at first in z plane, you can draw the figure, or you can understand what will be the figure. Then come with this function, input z equal to x plus yi, try to figure out u and v, and then you will get the parametric function. With from this parametric function, try to find a function for v equal to f of u, and already we have v equal to, that is v squared equal to 4 negative 4u. And if you want to learn how to draw the graph, you can use this concept. Clear? So whatever I have shown here, that is for rectangular part. That means we have taken x equal to 1. You can see for this we are inputting z equal to x plus yi. But don't forget that we have also another polar form, that is z equal to another form, that is polar form, z equal to r e to the power I theta. So for this, the function f of z can be u plus vi form, but this time u and v will be the function for r and theta. Is that okay? So if you have any problem in writing this one, if you are thinking that these notations are complicated, you can just write u and v, no problem. So let's take one example this time. Mm, at first, let me think about a problem. Okay, suppose we have to find the image. The question is always same. Find the image of a circle. Okay, let's use the find the image of the circle, and the circle modulus of z equal to 2. You can see that modulus of z equal to 2, and I am denoting that this is a circle. From week 1 contents, you know that if we have z equal to modulus of z equal to a, so what we have to do, this is from the concept of disk, annulus, or describing region. Okay, so instead of using this form x square plus y square equal to 2 square, in this question I have just written by this way, that is the circle is modulus of z equal to 2. Or suppose we don't have the proper information, rather we have find the image of modulus of z equal to 2. Now you have to understand what does it mean. It is actually a circle. How you will get the idea? That is where you have z. So where we have z, we have to input x plus yi equal to 2. So after this part, the result will, if we have modulus of real part plus imaginary I, that means we have a plus bi form, x plus yi form equal to something a. So this absolute value is same as this one, that is square root of real squared plus imaginary squared. And then you have to, in next statement, you have to remove this square root by squaring both sides. So you will get this one. So by using this concept, what we can do here, here we have real part and imaginary part. So it will be actually real part is squared, imaginary is squared, square root equal to 2. So that means you have x squared plus y squared, 2 squared. We have taken squared on both sides. Clear? Okay. Now let's complete our question. So find the image of the circle under the mapping or function. This time, let's say the function is f of z equal to 3z. So we have this function w equal to f of z. Can you see clearly my screen?
Yes, sir.
Okay.
Yes, sir.
So try to figure out the question at first. Find the image of this one under the mapping this. Now we have figured out that this is a circle in xy plane or z plane. So our mapping or function is given f of z equal to 3z. So this time, since we have modulus of z equal to 2, it is nothing but a circle, that is x squared plus y squared equal to 2 squared. Or we can write this one by instead of x plus yi, we can think about r e to the power I theta. That is here, since r is 2, you can see this is the radius. So it will be 2 e to the power theta. It will be in this form because a circle is thought to be this one, r e to the power I theta. So okay, let's draw the first graph that we have for z plane. So it is a circle with radius 2, radius 1, 2, 1, 2, 1, 2, here 1, 2. Now we can draw the circle. So this is the circle, x squared plus y squared equal to 2 squared, or now we can say modulus of z equal to 2. It can be also expressed as, you can see modulus of z equal to 2, so r equal to 2. That means from origin to any point in the circumference, the radius is 2. And this is the polar angle argument theta. So still you can see that since we have the circle, so what is the value of theta? What values it can take? That means for this circle, if we start from 0, 0 degree, 30 degree, 90 degree, 180 degree, 270 degree, 360 degree. So 0, that means theta is in between 0 degree to 360 degree. That means 0 radian to 2 pi. That means instead of x squared plus y squared equal to 2 squared, we can also write this one or this one in this way, r e to the power I theta, where theta is 0, in between 0 and 2 pi. Is that okay? So all the informations are looking different, but it is actually giving us the same criteria, that is, it is a circle. Clear? So this time we can think about polar form, or we can also think about rectangular, but since I have given one example for rectangular, let's say this time we want to figure out by using polar concept. So instead of z, now we can write r e to the power I theta, but in the previous problem what we have did, we have done this concept that where we have z, we are inputting rectangular form of complex number x plus yi, but this time we are using r e to the power I theta. You can also go by x plus yi, no problem. So 3, now what is the value of r? Already you have r equal to 2, so 2 e to the power I theta. Finally, you are getting 6 e to the power I theta. So that is f of z. Up to this part, it is enough to figure out what will be the actual graph in W plane. But if the question is, besides this, also find the real and imaginary parts of W equal to f of z, use polar form, let's say. So now we need to figure out real and imaginary part. So how we can do that? Here we have 6 e to the power I theta. So instead of f of z, we can say it is w. So 6 e to the power I theta. E to the power
Sir,
yeah.
sir, can you just scroll up a little bit? I didn't see the question actually, the extension part.
Okay.
So,
I have written that for this function f of z equal to 3z, find the real part and imaginary part of that function f of z.
Okay, sir. Thank you.
In
It's done.
some questions, you will find this type of pattern that
Yes,
is.
sir. I saw it. It's done.
And similar part we have done here. It's true that we are finding the image, but at the same time, we have to know how we can find u and v, or how we can find the real and imaginary part for a function, complex valued function. Okay. So you know that we have Euler identity, that is e to the power I theta is actually cosine theta plus I sine theta. So instead of e to the power I theta, what we can write? We can write cosine theta plus I sine theta. So that means we have finally 6 cosine theta plus I 6 sine theta. Now if we use parenthesis or group, then you can easily figure out that W equal to, it has U plus V I form. Let's write I on the right side. So U plus Vi. So you can easily figure out what is U and what is V. So here from this part we can have, so we are getting U equal to 6 cosine theta and V equal to 6 sine theta. Clear?
Yes, sir.
So up to now, whatever part we have found, that is parametric function. You can see here input is theta for u, and for v, we have a function for theta. So what we can do, if we need v equal to f of u, we have to find theta anyhow from this equation. So if we use this one, theta equal to, it will be, let's say, v over 6 equal to sine theta. That means theta equal to sine inverse v by 6. Now input theta here. That means you will get u equal to 6 cosine theta, 6 cosine sine inverse v by 6. And you know that by using trigonometric, this triangular format, we can figure out what will be this one. But I am not going into details. Already we have u and v part. Is that okay? This is u and this is v. So our target is to find the image of this circle. Modulus of z equal to 2. Already we have this one. You will understand now that in our given question, we have modulus of z equal to 2, what we are considering as 2 e to the power I theta in polar form, where just for the circle, we are denoting that theta is in between 0 and 2 pi. Then only it is possible. You can see radius is 2, so we can at the same time draw the graph. So this is modulus of z equal to 2. This is in z plane. So we have started with 0 and we are ending up at 2 pi. That's the information for this circle. This information, that is 0 to 2 pi, was not given in our question, but since it is circle, because we have x square plus y square equal to 4 or 2 square, so we can easily guess what will be the angle or what will be the values for angle. Is that okay? Now, after using the mapping, we are just summarizing all these things. After using the mapping 3z, we have finally found 6, let's say if we see this one, we have found 6 e to the power I theta. So 6 e to the power I theta. So just try to understand the concept that for 2 e to the power I theta, we have a circle here with radius 2. We have the same form here. That will be also a circle, but the radius is different, 6. So that means, now let's summarize. It is our z plane. With the help of mapping, what we can do, we can map the function with the help of this function, f of z equal to 3z. We can map modulus of z equal to 2. So it is 2 e to the power I theta. 1, 2, 1, 2, 1, 2, 1, 2. That means this is our circle. Clear? Similarly, for this function, the mapping finally gives us f of z equal to 6 e to the power I theta. So if 2 e to the power I theta is a circle, so 6 e to the power I theta will also be a circle. But the radius is different. Here we have 1, 2. 2 is the radius, but here we have 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now we can draw this one. So whatever graph we have previously, we have this circle. This circle is mapping to this one. It is our domain part. It is the range part. It is in z plane, that is in x-axis, y-axis. Here we have the w plane, that is u-axis, v-axis. So you can see whatever graph we have here, that is not same here. We have a magnification. Okay, that means this is the magnified form of the previous circle. So this is one mapping f that maps z plane to w plane, or this circle to this one. Clear? So this time we have found a similar shape but in magnified form. But for the previous problem, we had previously a vertical line, but after using the concept of mapping, we have found a parabola. So this is how mapping works. We can't show complex valued function in same plane because we don't have 4 dimension. Okay, that's why it's quite difficult. So we are using different planes so that we can easily figure out that what will be the graph in W plane, or what will be the value.
Sir, can we get the PDF version of this?
You will get both PDF and the recording. Okay, it is
Okay,
just
sir.
no problem.
Sir, I have a question.
Yeah.
Sir,
Right.
sir, when you are calculating in polar form, the theta will always be the same, just like the z plane.
Yeah. That
We will
will
not change the theta.
no.
If we don't know that the equation is circle or not,
Then there will be a problem. But
then
it's,
it will be better if we do in Cartesian form, right?
yeah, it will be better. But whatever I have tried here, just I have tried to show all the forms, that is rectangular form and polar form. Okay.
Okay, sir.
Yeah, you were right that always it will be not same. Okay, so that means Cartesian is the perfect form for this one. But remember, that for all problems, Cartesian is not helpful. Let me show another one. You will see. Suppose we have f of z equal to z to the power 4. If I ask you, find the real and imaginary part. We are not discussing about mapping, just we want to figure out what is the real and imaginary part. So again, I am making it complicated. Let's say we have -6. So if we use rectangular form, x plus y I power -6, we are just familiar with a plus b whole squared, a plus b whole cube. Okay, we also know a plus b power 4 by using binomial theorem. We can expand. We can also expand this one. We can use also Pascal theorem, that is a triangle form. But it is getting difficult. But that means the insight is we have to memorize all these things. So in this case, rectangular form is not helping us. Is that okay, Afrit?
Yes, sir. Got it.
Because we can't expand this one. If we know the expansion x plus y power -6, we can easily expand this one, but that is a concept of binomial theorem. So rectangular form is not applicable. But here we can also write f of z equal to f of, that is z power -6. Now instead of using rectangular, what we can do, we can think about polar form. Clear? And polar form allows us to take this identity. If we have AB power m, you will find A power m times B power m. Clear? So that means you will get r to the power -6 e to the power I. That means here we will have -6i theta. Clear?
Yes, sir.
Okay, using this concept. Now, our target is to find the real and imaginary parts. So remember in your first quiz, that means the quiz that is coming, you will get similar type of questions there. Okay, so you have to know how we can find real and imaginary parts. So let me take another page. So f of z is found to be r to the power -6 e to the power -6i theta. Our target is to find u and v. F of z will take finally the form u plus vi, but this is not u plus vi. Here plus is missing. So that's why what we can do, we can think about Euler identity. So r power -6 e to the power, let's say this is -i 6 theta. Clear? I'm just
Yes.
writing negative I before. So we have Euler identity, e to the power I theta is equal to cosine theta plus I sine theta. Similarly, if we have e to the power -I theta, we will get cosine theta negative I sine theta. So we have actually these two. Is that okay?
Yes, sir.
For e to the power positive I theta, we will get cosine theta plus I sine theta. E to the power negative I theta, we will get cosine theta negative I sine theta. Actually, this part is the evolution of this one. That means, let's say, instead of e to the power minus I theta, we can write this one as this. Now, we can apply the first formula. E to the power I theta is cosine theta plus I sine theta. So we have cosine negative theta plus I sine negative theta. You know that cosine negative theta is actually cosine positive theta, right? But sine negative theta, that negative will be pulled out. So we have I sine theta. So that is how we can find this formula. So finally, we have e to the power I negative I theta equal to cosine theta negative I sine theta. Is that okay? This is the generalization. Clear? So here you can
Yes,
see,
sir.
here you can see that this is our theta position. Now we will use this part. So what we can do, r to the power negative 6 cosine theta, that is cosine 6 theta negative I sine 6 theta. So we have r to the power negative 6 cosine 6 theta negative I r to the power negative 6 sine theta. So this is f of z. Now we have the form a b, because subtraction, since subtraction is one kind of addition or addition, so here we can see that r to the power negative 6 cosine 6 theta plus negative r to the power negative 6 sine 6 theta I. Now we have u plus vi. So this is f of z. So that means here we have figured out that u equal to r to the power negative 6 cosine theta, that is the real part, cosine 6 theta, and v equal to r to the negative, you can see negative r to the power negative 6 sine 6 theta. Why we have used plus? Because always we have x plus yi form, real plus imaginary I. So real plus imaginary I. That means this is u and this is p. So those who are thinking that always we have to use Cartesian form, but actually sometimes Cartesian form will not give us the exact part. So at that time, polar form will be helpful. So in summary, we can say both polar and rectangular forms are helpful. Is that okay, everyone?
Yes, sir.
Okay. So let's move to, so whatever we have discussed up to now, that is complex variable and mapping. So let's focus on the limits. And just like this, because this. So here we have epsilon delta definition. The first definition is coming epsilon delta, but I think for this quiz the proofs will not be here, so that means you can skip this epsilon delta form, but still I will try to discuss here. So up to now you are clear that we can express any function f of z in u plus vi form. U and v can be a function of x comma y, or it can be a function of r and theta. So now the concept of limit is coming. So first of all, the limit definition is, suppose we have this function and we are trying to check the limiting behavior of this function f of z or w at z tends to z0, that means at z0, and there may be a value that is L. It is a complex number finally. So this is the normal form, that is the general form. It is just going with our real valued function, that is limit you're often using x tends to a f of x equal to L. Is that so? So in complex valued function we use this notation. But the epsilon delta definition that we have as the first concept in limit, here you can see it is L, and this is the function f of z. We are trying to check the limiting behavior of that function when z is approaching to z0. If this limit exists, that means limit may exist, it may not be, okay? That means we may get undefined part. At that time we can say limit doesn't exist. So here you can see that I have written limit z tends to z0 f of z equal to L. This is the formal definition, but the epsilon delta definition says that it has an alternative form f of z. It is the function f of z, and suppose you have the answer of that is the limiting value L. We have to prove that limit of this function at z when z tends to z0, that is equal to L. So for this we use epsilon delta. So absolute value of f of z negative L will be less than epsilon. So if so, then that means here epsilon is positive value. For epsilon greater than 0, if there exists a delta that is also a positive value, so that means if it is possible to find delta greater than 0, which follows such that we can write in this way z negative z0. From where it is coming, here you can see z0. So z negative z0 must be less than delta. You will understand this concept. Okay, first of all, try to focus on the target. Our target is to find if there exists a delta. That is the main part. Our target is to find delta. Okay, you will understand if I give you one example. Let's take limit z tends to 0, z over z, this one, z over z bar. Okay, at first, let's take another problem. For this, we will show in normal process, but let's take another one. Limit z that is approaching to 1 plus I. So 2 plus I z. That means, can anyone please multiply this 1 plus I? What will be the result? It is most probably 2 plus I, 2I plus I squared is negative 1. We are getting 2 negative 1, 1,
1
3I.
plus 2.
1 plus 3I. Okay. So we can easily, by using our normal concept, a general concept, we can directly say that the result of this limit is this. Is that okay? Now we
Yes.
have to, we are targeting for proving that this function f of z, when z tends to, z is approaching to 1 plus I, the result of this limit will be 1 plus 3I.
Sir, I have a question.
Yeah.
What is the difference between normal limit and complex number limit? I think the operation is almost same.
Same. But the only difference is here in real valued function, you have only x as real value. That is, x is a value that is from real number set. But in complex valued function, z is coming from complex set. Is that okay? This is the main difference. But the formal definition is same. For epsilon greater than 0, if there exists delta greater than 0, we will have this condition. That means we need to find one delta. You will understand if we try to show this one. So first of all, can you figure out what is f of z? This is f of z. Limit z tends to z naught. And this is L. We are just comparing with the main definition of limit. Is that okay? So from here, we can collect that f of z equal to 2 plus I z. Here, L is the result, 1 plus 3I. And we have found z naught as 1 plus I. So let's try to prove that the limit of this function at 1 plus I is equal to 1 plus 3I. But for your upcoming quiz, you don't need to show all these things. These proofs will not come, will not be there. Okay, you can just focus on the problem solving part. Whatever I have done here, limit of this function at z tends to 1 plus I will be then this, and this. Is that okay? Clear? But I am trying to make you understand about the epsilon delta proof.
Yes, sir.
Okay, so first criteria, it is already we have. For epsilon greater than 0, absolute value of f of z negative L must be less than epsilon. Okay, so we are taking any arbitrary epsilon. Let's say for epsilon greater than 0, this will help you in understanding the epsilon delta proof. So what we have, modulus of f of z negative L less than epsilon. So just we need to place this. So here in f of z, we can place 2 plus I z negative L. L is this one, 1 positive 3I less than epsilon. Clear? Oh, there will be a parenthesis. Yeah. Is that okay?
Yes, sir.
Now,
Yes, sir.
our target is to find a delta that is greater than 0. That must be a positive number. That will be a small value for which this condition holds. Is that okay? So let's try to figure out. Our target is to prove modulus of z negative z naught less than delta. So let's write the proof at first. The final result should be z negative z naught less than delta. That means z negative z naught. What is z naught? 1 plus I, right? So
Sir,
finally, in somehow we have to prove this one by using the analytical process. So okay, forget about the last part. Remember, epsilon is greater than 0. This is a positive quantity. So from this, we are trying to prove. What we can do, actually proving by epsilon delta deals with some properties. So here we have, can we write this one? we can factor out 2 plus I. So z negative 1 plus 3i 2 plus I. Can you do that?
Yes, sir.
Yes, sir.
Okay. Try to understand the process, because this process will be always same for every problem. In complex analysis, we have a number of proofs or theorems. Okay. Now we can see that, think about, this is a complex number, this is another complex number. So you know a property in week 1 you have learned this. If we have modulus of z1 times z2, so what we can write, we can separately write modulus of z1 modulus of z2. Clear?
Yes, sir.
So we can write this one modulus of 2 plus I and modulus of z negative 1 plus 3i 2 plus I less than epsilon. I have another consultation tomorrow. Okay, and I will inform you on Slack when I will take. Okay.
Yes, sir.
Sir, can you take the consultation in the morning or in the noon? Because we have quiz
I
in
will
the morning.
I'll try to take the consultation as I am taking today. That means at morning.
Okay, sir. Thank you.
Okay. Now we can see that modulus of 2 plus I. So think about, I will conclude the session after this proof. Is that okay? So this is going to be the last
Yes,
part
sir.
for this session.
Okay, sir.
Okay. So modulus
Sir,
of
you
2
will
plus,
upload the video on the
yeah, I will upload the video within 1 or 2 hours.
sir
Sir,
on bus or
No, 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 no.
sir, ভিডিওর
On
সাথে
Slack.
কি এই
Okay.
পিডিএফটা একটু দিয়ে দেন?
I will give you the link. Is that okay?
on Slack?
স্যার আই
On
মিন
Slack.
এই পিডিএফটা কি
Oh,
দেওয়া যাবে
thank you.
যেটা আপনি লিখছেন?
Yeah, I will also deliver the PDF.
থ্যাংক ইউ স্যার।
So you can see there is a complex number and we have to find the modulus of this. So think about this, that we have, suppose z equal to 2 plus I, and we are asking for the modulus. Modulus is this. That means it is by x squared plus y squared. So here we have x squared 2, that is 2 squared, plus y is 1 squared. That here we can write 1 squared. That means 4 plus 1, 5. Clear? So what is the modulus? Root over 5. That means modulus of z is root over 5. So I have done this part in side note. So modulus of this one is actually root over 5. Is it clear?
ইয়েস
Yes,
স্যার।
sir.
And here we have another part inside this. So z negative. Okay, you can see p by q form, 1 plus 3i 2 plus I. That is also a complex number, but in week 1 you have dealt with this type of problems. That is, we can express this one in a single form a plus bi by the concept of rationalizing. If we rationalize this one, that means whatever part we have in denominator, here you can see 2 plus I, we can make this p by q form to a plus bi if we multiply the opposite, that is conjugate of the denominator, that is 2 plus I. We can multiply 2 negative I on both upper part and lower part. Clear?
Yes, sir.
So here we have epsilon. So now root over 5 modulus z negative here we have 2 plus I. and the conjugate will be 2 negative I. Is that clear? And on right side we have less than epsilon. So we are multiplying 2 negative I on both numerator and denominator. Is it okay? If we cancel this and this, we are getting the same thing. So no problem. It doesn't affect our previous statement. Okay. So let's come from this one. Root over 5. Z negative. Now we have to use algebraic technique, that is multiply this one. 2 times 2, that is 4. It is up to you. You can directly say, or we can calculate. That is 2 times 2, 4. 2i negative 2i negative I squared. And in upper part, please try to check whether I am writing the right thing or not. So 2 plus 6i, if we multiply 1 and negative I, it will be negative I. And finally 3 negative 3i squared. Is that okay?
Yes, sir.
Our target is to raise to a plus bi form. So that's why we are rationalizing this. The concept that we have applied here, we are multiplying with the conjugate, both in numerator and denominator. It is called rationalizing. And a plus bi is the standard form of complex number, or x plus yi is the standard form of complex number. So we are going to have that part finally. So root over 5, z negative. So 2, and then 6i negative I. You are getting plus 5i. From this part, I squared is negative 1. So negative, negative, positive, you are getting plus 3. Here we have 2i, negative 2i cancelled. So we are getting 4. Negative I squared is negative 1. So we have this. Is it okay?
Yes, sir.
So finally, root over 5. We have taken one random problem, but we are trying to check whether the result that we have here is actually okay or not by using epsilon-delta proof, epsilon-delta method. So let's try to figure out. So z negative 2 plus 3 in upper part, we are getting 5 plus 5i. 4, you can say it is 4 plus 1. So here we have 5 less than epsilon. So here we have epsilon root over 5. So square root of 5 modulus of z negative. You can see this time we don't have any complex, that means any imaginary part. So what we can do, we can factor out 5. We have 1 plus I, 5 less than epsilon. Now we can easily say that we have 5 and 5 are getting cancelled. So we are getting, I am on the other screen. Can anyone please inform me whether the session is recording or not?
Yes, sir,
Yes,
it's
sir. It's
showing.
recording.
Okay. So here we are getting modulus of z negative 1 plus I epsilon. If I use another color, so this is just for the modulus. Okay. So what we can do now, modulus of z negative 1 plus I less than, we can transfer this root over 5 on the other side. Clear? So suppose epsilon, we have already considered previously that epsilon is greater than 0. That means suppose we have 2, epsilon is 2, 2 is greater than 0. And now 2 by root over 5, that will be also greater than 0. Isn't so?
Yes, sir.
So that's why epsilon by square root of 5, that will be a number. So here we have z negative 1 plus I less than. Now we can write this one as a number, any positive number. Let's say this is delta. So our target is to prove finally that we must have, if we can show there is a positive quantity finally after using all the algebraic manipulation from this part, then automatically we will get modulus of z negative something, that will be z naught, which is less than that positive value. Clear? So you can see we are mentioning that this is a number delta. Now let's check modulus of, our target is to reach to this one, modulus of z negative z naught, that should be less than delta. So it must be same. Let's see. Yeah, we have z naught equal to 1 plus I. We are able to prove. Clear?
Yes, sir.
After this whatever calculations we are starting from this part, you can see we have done a lot of calculation here. That is, we are finding the modulus for the first part. We are using this concept. Then we are rationalizing this P by Q form. And finally, after algebraic manipulation, we have reached to the conclusion that we have found a positive delta for which we have this condition modulus of z negative z naught, that z naught is in our limit. So finally we can say that limit z tends to z naught, f of z is actually L. For the function, we can say limit z tends to z naught is 1 plus I, and the function that we have started with two plus I z. So the function is 2 plus I z is equal to the result. What is the result? 1 plus
1 plus 3i, sir.
Thank you. So 1 plus 3i. So we can easily prove that this function with this limit is approaching to 1 plus 3i. So this is the epsilon delta proof. I hope you have understood. Clear?
Yes, sir.
Yes, sir.
But this
Yes,
is
sir.
important for your, suppose for midterm or assignment or something others. But for the upcoming quiz, for the same problem, what you can do, now I am using another technique, that suppose we have to find limit z tends to 1 plus I, 2 plus I, z. So we need to find the limiting value for this function. So what you can do for this, all the theorems can be applied, or L'Hopital's rule can be applied. So you can do anything. Okay, so that means limit z tends to 1 plus I, 2 plus I, in the place of z, what we can do? Okay, we have a property. We can still write this one here, that instead of writing again, we can directly say 2 plus I. We are inputting the limiting value 1 plus I. Since it is not in 0 by 0 form, it is just in normal form. If we have 0 by 0 form, that is an indeterminate form, then L'Hopital rule can be applied. It's not L'Hopital, it's L'Hopital. Okay, so here we have,
Finding limit using definition.
then
if I
that
not wrong.
finding limits using,
Definition.
I have already mentioned that for your upcoming quiz, definitions will not come. Okay, but If definition is mandatory, then you must have to use epsilon delta.
Sir, if there is in a written exam, is there is a question finding the just limit,
Then you have
on that time.
then you have to apply this concept, this one.
Okay.
If you have to you have to prove by the definition, then you must have to apply epsilon delta notation. Clear? And for epsilon delta proof, whatever process I have applied, whatever calculations I have applied here, you can have a look, you can understand the process. Then for every problems, the process is same for every proofs. Clear? So our result is 1 plus 3i. But still, we can solve this one by another technique. Let's say limit z tends to 1 plus I. Do you understand? This is our answer. This is suppose method 1.
Yes, sir.
I am showing another method. Because you are familiar with some theorems that I'm taking the same function 2 plus I times z. So you know a theorem that if we have product limit z tends to z naught f of z z of z, what we can do, you can see, let's say this is f of z, this is g of z. What we can do, we can separately write limit f of z times limit z tends to z naught g of z. Is that okay? Limit
Yes,
of
sir.
product is the product of the limits. That is the theorem. Already, I think you know. So what we can do here, limit z tends to 1 plus I, 2 plus I times limit z tends to 1 plus I times z. Clear? So since it is a constant, can you understand that this is a constant?
Yes, sir.
So since it is a constant, suppose limit x tends to 100, 1. What will be the limiting value?
By
This
1.
1.
1.
If we have 1000, still it is 1. So using this concept, since this is the constant, so we can say that limit of a constant is constant. So that means we can write for the first limit, let's group this one. We have total 2 limits here. So for the first part, here we have, which one will be the answer? 2 plus I. Yeah. And then limit of z. So where we have z input, now 1 plus I. Now multiplication is 1 plus 3i. So we have done actually the same thing here, but actually the concept that is working behind it is this one. Okay.
Okay, sir.
So whatever I have discussed today, that is on complex variable and mapping, and just I have discussed how to use epsilon delta. So in next consultation, I will try to discuss about differentiation. Okay.
Sir, limit ke epsilon delta শিখলেই হবে or we have to do more?
For the upcoming quizzes, you don't need to have a look on epsilon delta. Rather, please try to focus on more and more from problem solving.
Okay, sir.
Okay, that means directly you can calculate.
So then limits at infinity won't be necessary because as it is consists of 3 theorems.
Okay, suppose you have limit z tends to infinity 1 over z. So we have a theorem that limit if z tends to infinity.
So there are three theorems
Yeah,
there,
we
right?
have actually three theorems. Let me recall the theorems at first. The first theorem that we have, can anyone please tell me the first theorem? Then I can automatically figure out what are the theorems. Maybe the first theorem is starting with limit. So far I know that is
Z
limit z
naught,
tends to z naught f of z
f of z
will be
equal to
infinity,
infinity.
infinity if and only if, right?
Yes, sir.
If and only if
Limit z tends to z naught 1
z
by f of z.
tends to z naught 1 by f of z equal to obviously 0, right?
Yes,
So
sir.
try to understand the inner part of this theorem. Actually, we can, whatever we are practicing from the very childhood, we are doing like where we have infinity, we are in, where we have z, we are inputting. Okay. Okay, sorry for the inconvenience. Here, where we have z, we can just input infinity. This is our practice from the very childhood. And you know that anything by infinity, that is a by infinity, that is 0. But actually, we are missing some parts here, just like the previous problem. We have skipped some part. You can see the middle parts are the theorems. Is that okay? So
Yes, sir.
actually, for your quizzes, you can understand by this, where you have z, you can input infinity. Then you are getting 1 by infinity, which is 0. But with
So
this
we
theorem,
can
with
directly
this,
put the value there, right?
yeah.
Yes, sir.
But if
Okay.
it is 0 by 0, then you can apply L'Hopital rule. I am coming up to this one. I will just give 5 minutes, okay? Because I have another consultation.
Okay, sir. Okay.
Okay. So here, result will be 0. But the same thing I'm trying to discuss with this theorem. Try to understand the theorem. So here, the first part is f of z. So here, you can see that the f of z is which one? F of z is 1 by z, right?
Yes, sir.
So you can easily see that first of all, let me figure out by this way. Let's say this one is our f of z for now. So if we think that this denominator part is f of z, and if we input this z naught there, that is limit z tends to infinity. So here we have limit z tends to infinity z. So obviously that this will be infinity, right?
Yes,
That
sir.
we are here. Now our target is to find the total part. So here you can see that if for a function we are getting infinity, so for some function z we are getting infinity, then the reciprocal of that, that means 1 by f of z, will be 0 at that limiting part. So here we have already considered f of z as z. Now let's find, so here f of z equal to z. Our target is to write 1 by f of z. So what will be 1 by f of z? 1 by z, right?
Yes, sir. 1 by infinity then.
Yeah. So we are getting 1 by z, that is this one. That is this one. So By this theorem, let me zoom out this one. If this is infinity, if z is giving us infinity, then 1 by z will obviously give us 0 by this theorem. So 1 by z
Yes.
is giving us directly 0. This is the insight of the theorem. Okay.
Okay,
Theoretically,
sir.
all the explanations can be given, but whatever we have practiced, okay, we are practicing with
Sir,
the direct limit. Yeah.
sir, my question is, do we actually solve the problem by theorem or we just prove something here?
No, no, Nibras, you don't need to show all the steps. I have already told that you can skip all the lines. Okay?
Okay. Okay,
Because
sir.
because in some parts you will find a complicated function where if you try to use the limiting concept all the time, then you will get stuck. Okay? The limiting concept, the theorems are the main pioneers. Okay, but you can just for your betterment, you can skip your lines. Okay,
Okay, okay, sir.
but for assignment, I will suggest you after if you are figuring out what will be the result, then you can just mention in side note that we are using this theorem. So then there will be no problem. Clear?
Okay.
But
Okay, sir.
first problem, your first task is to solve any specific problem. Your first task is to find the answer. Clear?
Okay, sir.
So okay. Uh, do you understand this theorem clearly?
Yes, sir.
That means this part we have taken as f of z. So if f of z is infinity, that means if z is automatically, you can see z for z tends to infinity is giving us infinity, then obviously 1 by z, that is obviously 1 by f of z will be 0. So 1 by z is 0. That is the thing. This is the theorem. But what we are doing here, we are using our old practice. Clear? That is actually a bad practice, but we have to come by this way. Your first target is to solve the problems. So, okay, I hope you have understood some parts from this session. And now it is the time to have a look on the contents again. Okay, so I'm, if you permit me, then I am concluding the session here.
Yes, sir. Of course.
Okay,
Yes, sir.
and
Sure.
just before leaving, can you please uh, leave your email here on the chat box?
Sir, the G Suite one or the normal one?
You can give anyone.